Our next topic of discussion is how to bring up serial point-to-point links. Now, in our lab topology, if you have noticed, we have a serial connection denoted by the Thunderbolt in the Cisco vernacular between router 201 and router 1. Router 201's serial 010 is connected to router 1's serial 000. Now, in the real world, routers are seldom connected back-to-back like this. What a router will do is have a serial connection to something called a CSU-DSU, which is the termination point or the demarcation point for the ISP. That's where the ISP's responsibility ends and your responsibility begins. The CSU-DSU then connects to the ISP cloud, and on the other end, there will be another CSU-DSU connecting to your remote site router. A CSU-DSU provides a few functions to the router. Firstly, it provides what we call clocking, or the physical bit transfer rate between the two end devices, or between the two routers that are your local router and the remote router. The CSU-DSU is also called a DCE device, or a data connection equipment device, or data connecting equipment device. A DCE device is the device that provides clocking. A router, on the other hand, is considered a DTE device, or a data terminating equipment device. Now, the CSU-DSU provides clocking for the router, which is the physical bit transfer rate between the CSU-DSU and the router. As we do our lab, we will be exploring the show IP interface brief command. In this command, you will see there are three fields. The first two fields. The first one is method. This denotes layer 1. And the second one is protocol. This denotes layer 2. Now, when you execute the show IP interface brief command, and you see, well, when you execute the show IP interface brief command and you have done your due diligence, you have assigned an IP address and you have no shut the interface, but you still see down, that means this is a layer 1 issue. So no amount of you troubleshooting sitting on console will help. You need to go check your cabling. If you see up, down, that means this is a layer 2 issue. So down, layer 1 issue, up, down, layer 2 issue. Now with layer 2 issues, there could be one of three things wrong. So with layer 2 issues, you could either be missing keep alives, so no keep alives are being sent. The second issue could be mismatch encapsulation, and I will explain this further when we get to our lab. And the third issue could be no clock rate set on DCE end. In the real world, as I said, CSU-DSUs, which actually the acronym stands for Channel Service Unit, Data Service Unit, a CSU-DSU will provide clocking. But in our lab, these two devices, these two routers are connected back to back. This is what a serial cable looks like. And one end of the serial cable, if you will see, says DCE, or actually this side says DTE, and then the other side actually says DCE. Whatever router gets this side of the cable, the one that says DCE becomes the DCE and now must provide clocking, and whatever side says DTE, whatever side gets connected to the DTE end becomes the DTE side. A CSU-DSU is nothing more than a digital modem. So a CSU-DSU will terminate a digital signal just like a regular modem will terminate an analog signal. Once again, the DCE device, which could be a router if two routers are connected back to back, and the DCE end of the cable goes into one of the routers, that router becomes the DCE side, or a CSU-DSU is a DCE device. DCE devices provide the clocking, which is the physical bit transfer rate between two ends. Now we're going to move on to the lab. But right before we do, I want you to think about what the mask is going to be on this point-to-point link. I'm going to assign the address 200.200.200.0 on this link. However, if you thought about it, the mask is going to be /30. Remember from our subnetting lecture yesterday, I said that the /30 mask is used over point-to-point links. And I'm going to keep router 1 as .1, and I'm going to assign .2 to router 2. For the 200, 200, 200, 0/30 network, the two valid addresses are .1 and .2, because the value of the last bit turned on for a /30 mask is 4. So you get a block size of 4. So the first network goes from .0 to .3, .1 and 2 being the valid addresses, and .3 being the broadcast. Okay, now we'll move on to the lab.